Hi everyone, welcome. I'm Archana.
Hi, and I'm Soham, and we're here to talk about our open source project ScaleDown, which is helping to democratize TinyML education.
TinyML or edge computing is a machine learning paradigm where we optimize neural networks so that they can run on microcontrollers and other resource constrained devices. TinyML has become more important with the popularity of the Internet of the Things and deep learning. Deploying neural network on such devices is difficult due to how large they are in terms of memory footprint and the number of operations needed to execute them. So, we need to optimize and scale down neural networks to deploy them. TinyML combines techniques from software development, machine learning, and electronics engineering to run ML models on embedded devices. This means that someone who works in this field needs to have a wide breadth and depth of knowledge in each of these fields. Another problem is that there aren't many resources focused solely on teaching the relevant TinyML concepts, and it can be easy to get lost or stuck when learning this with the typical learning resources. While TinyML hardware may seem cheap, they are still expensive and inaccessible to a large group of people. We believe that this is one of the most significant factors stopping more people from learning TinyML and is one of the primary reasons we created ScaleDown. Finally, tools for building TinyML applications are not helpful for beginners to get into the field. The tools landscape is fragmented with different frameworks supporting different algorithms and only models trained with their framework. This makes it a nightmare for beginners who don't know which tools, frameworks, and hardware are compatible with each other. All of these problems motivated us to find a way to provide the community with easy ways to learn TinyML and become TinyML engineers. One of the main goals of our project is to provide community with free and open source resources they can learn from. These will include not only written materials like blogs, books, and articles, but also video tutorials and study groups to learn together. We want these resources to be a healthy mix of academia and industry, so we will also do paper reviews and create tutorials for projects. To help reduce the financial burden on beginners, we want to build a hardware library. The library will be free to use, so users can borrow hardware to learn, practice, and develop and test their projects. Finally, we want to create a framework that is a wrapper over common TinyML tools. This will make it easy for beginners by providing them with a standard API to do similar tasks regardless of frameworks they know or use. We hope to make ScaleDown hardware and software agnostic by adding support for new algorithms and the latest hardware and software tools. For instance, at the moment we support conversions of model from 3 different frameworks and 3 different optimization techniques too. All this will help people build a portfolio of projects with multiple hardwares that they can leverage to get career or internship opportunities.
Now, we'll see an example of using ScaleDown to train and deploy a model. First, we'll import the packages we need. This includes the APIs for knowledge distillation and weight quantization. We can load models from either a model file or from code. Next, we can also load the training data and then specify the specifications we want to use to train our model. We can pass these to the API for knowledge distillation that's given by ScaleDown. Training a model is just one line, which is kd.trainStep. After the model gets trained, we can benchmark the student model to see its performance. We can also quantize it to float 16 and then create a deployment package that we can deploy to our target device, which in this case is a Raspberry Pi. Now, let's see the result when we run it on our host device. First, we load the model and the training data. Then, we train the model with knowledge distillation. After the model gets trained, we can get a benchmark report which gives us the flops for each layer as well as the breakdown for each layer type. Next, we can quantize our model and then deploy it.
So you can get involved in various ways. you can check out our page and check out the library. We have the list of hardware and specs available. Through the list of hardware and specs, you can go through the hardwares that are present. We have both microprocessors and microcontrollers present. You can also move around the list to see the types of microprocessor and microcontrollers present and see the ones you like. And then you can check on how to request for hardware. We have a very quick infographic here which explains the process, and to actually request, click on this form. You can also donate hardware. There is one more way in which you can get involved. So for donating hardware, you just have to go to this part of the website and click on reach out. And apart from that, you can also be a part of our team. To be a part of our team, you can move under the collaborate with us section and click on join us, and then you can check out the team we have currently. So we already have a few members, and we also have the join us button right out there. We hope we have gotten you interested in our framework. Please do check out our work by visiting the link in the QR code. We would love to collaborate with you to help improve our framework, build educational materials, and work on research projects. You can reach out to us via Twitter or join our Slack. We hope to hear from you soon.